Okay friends, welcome to part 2 of our video presentation on business intelligence. Now we concluded part 1 of this video presentation by discussing some of the main BI targets or issues or goals. So we said that the main targets of business intelligence include integration, the development of one single or a few related BI applications for the entire enterprise. Number 2, infrastructure, which is creating an infrastructure that can support not only current but also future BI needs. And also organizational transformation. At the end of the day, any kind of BI initiative needs to help employees make better decisions, and those decisions need to lead to greater or enhanced organizational performance. Now let's look at a couple of case studies in relation to business intelligence. Now the first case study is a study by a company called 3M. Now 3M is a well-known company, well-known conglomerate responsible for many consumer and not consumer and industrial products. One of the most famous products of 3M is their Post-it note. They were the inventors of this concept of using like a low-strength adhesive on a sheet of paper so you can attach it to a door or computer monitor. Now the problem that 3M discovered was that its divisions operated independently and had separate decision support platforms, meaning separate applications and separate databases. Not only was this costly, it was also impossible to integrate the data and present a single face to customers. Now you probably understand why storing data in several different locations creates this problem, because those several different databases will be maintained by different people. They'll be using different conventions to store information about the same kind of entity, let's say about customers. For example, customer name can be spelled in different ways. Customers may be assigned different IDs in a marketing database and in an accounting database. So all this leads to data problems. Now also for 3M it resulted like a degree of miscoordination. For example, sales representatives did not know what business customers were doing with other 3M divisions. So the solution was to develop an enterprise data warehouse, meaning like a centralized location for storing all organizational data. Now the costs of building the centralized enterprise data warehouse for storing all organizational data in one central location was offset or covered by savings resulting from the consolidation of the various platforms. Meaning instead of paying separate licenses and maintaining different databases in different divisions, there was one central license, one central database, one central platform. So that helped them offset the cost of creating a centralized data warehouse. But ultimately speaking about the third target of business intelligence, which is organizational transformation, this allowed 3M to operate as one single integrated company, at least on the dimension of sharing and storing data. Now 3M, to kind of take this case study a little bit beyond simple business intelligence and data storage. Now 3M is quite well known for using all kinds of strategies and tactics for ensuring collaboration. So one thing that they do, they create like a directory of all employees within the organization and their expertise. So if somebody is working on a project and that person needs to ask somebody's advice. Advice of a person who has expertise in a different area, they can easily retrieve it. Now, the other thing that I've heard, from one of the 3M officers, and I think the title of this particular manager was Chief Innovation Officer. He said that they are investing quite a bit of resources into coffee shops, located within the premises of 3M. Because when people go to have some coffee, they also, meet other people, they, talk about their ideas, their current project, and this seems to ensure collaboration and, most importantly, creation of new innovative products for 3M. So that's one case study involving 3M. Now the second case study, I would say it's a bit more significant, and I'll tell you why at the end. This case study involves Hara's Entertainment. Now, Hara's Entertainment is, I guess you can also say it's a conglomerate under which umbrella we have several entertainment companies such as casinos, different event companies and so forth, hotels. In the early 1990s, the gaming laws changed to allow gambling on riverboats and Indian reservations. So Hara senior management saw this as an opportunity to expand and operate all Hara's properties in an integrated way. Now, in the past, properties were run as independent fiefdoms or independent organizations. at the heart of this new business model was the collection and use of customer data and the creation of a customer loyalty program, the so-called Total Rewards program, that encouraged cross-casino play. Now, the key idea here was that an IT infrastructure, BI infrastructure, was created, and that infrastructure shared data about customers across different venues and locations operated by Hara Entertainment. So by aggregating all this data together and storing it in a centralized location, let's say data from casinos, from hotels, from special events, Hara Entertainment was able to understand better its customers, so what they like, what they don't like, and then also gear their discounts, their marketing, their loyalty programs, customize those offerings specifically for individual customers. So that really enhanced their marketing effectiveness, and at the end of the day, it all translated into higher revenue generation and higher profits for the company. So that's the case of Hara Entertainment using business intelligence to improve their marketing initiatives across all of their venues, all of their properties. Now, the reason Hara's case is quite significant is that one of the people involved with Hara Entertainment was Tom Davenport. Now, Tom Davenport, I think I'm sure he has many occupations and many talents, but one of his main occupation is a university professor. And I think at some point, Tom Davenport, he kind of quit, or he took a leave of absence from his main job, which is being a professor and lecturer, and he went to work for Hara's Entertainment. And I think he worked there for quite a while. He worked there for at least a year or two. And based on everything that he's seen, he wrote this book, Competing on Analytics. And I think this book was published around 2005, 2006. Now, the reason this book is quite significant is that it gave a tremendous boost in popularity to the entire business intelligence movement. Business intelligence has been around for quite a while, I would say since 1990s. But this book and the kind of work in terms of consulting and public speaking that was done by Tom Davenport based on his experience at Hara Entertainment created a huge boost to the entire movement. So in many ways, Tom Davenport and his book, they became like, one of the visionaries, one of the leading thinkers in the field of business intelligence, and all of their hard work, the hard work of Tom Davenport and his colleagues over the years, translated into increased popularity and acceptance of business intelligence movement across different industries and organizations. Now, so how does business intelligence look like from the architectural standpoint? So that's what we're going to talk about now. What you see here, you see the so-called generic BI architecture. Now, generic BI architecture usually involves the following components. First of all, you have source systems. Now, source systems can be thought of as individual databases or files that are integrated together and then being stored in a centralized enterprise data warehouse. Now, the kind of source systems and the number of source systems will largely depend on the type of BI application. For some simple BI applications, you can use just one single database, one single source of data, and of course that makes things very simple. But if we're talking about a complex BI initiative, complex BI application, then most likely you'll have to pull together various databases, both internal and external. For example, let's say if you have a university trying to engage into data-driven or business intelligence-driven initiative aimed at improving student retention, then they may want to use several sources of data. First of all, they may want to use their own internal data about student academic performance. They may use external data about student high school performance, the kind of GPA they had in high school, the kind of grades they had, the kind of test scores they had. And then this can also be combined with advising data, for example, like a database maintained by advisors, so that they know more about the kind of issues that were experienced by students throughout their studies at the university. So all those data sources, they have to be integrated together. Now, after data is integrated, it's being stored in a data warehouse. Data warehouse can be thought of as a centralized storage for all data within an organization. So it's like a library of organizational data. And warehouse, the word warehouse means like big, big repository of data. Now, in relation to data stored in a data warehouse, you may want to use something called metadata or metadata. Now, metadata is basically data about data. So this database contains information about data being stored in a data warehouse. For example, the kind of databases that are in there, the kind of attributes, the properties of those attributes, and all those things. After data is being stored in a centralized data warehouse, then dependent data marts can be created for specific BI applications. Now, a dependent data mart is a subset of the overall data collection found in a data warehouse. For example, an organization may want to create a specific data mart for the marketing department so that they can, analyze, let's say, their consumer data. So that would involve taking some of the data from the centralized data warehouse and singling it out or putting it into one dependent data mart. Now, the reason it's called dependent data mart is that it depends on the data contained in the central data warehouse. So that's why it's called dependent. And there can be many dependent data marts depending on the types and the quantity of BI applications that an organization may have. But the key here is that no matter what kind of dependent data mart it creates, it draws data from a central location. So if those two dependent data marts have overlap, let's say both of them contain consumer data, then this consumer data will come from one single source and it will be identical. Most of the time it will be identical, so that there's a single version of the truth, as we mentioned previously. And then in relation to this BI architecture, you have metadata processes, processes for capturing documentation in relation to the data that you add to your data warehouse or to a data mart. Then you will have certain processes or policies in relation to data quality, how to enter data, how to update data, how to do data quality audit. So those are more managerial processes. So they will be included as a part of BI architecture as well. And then high-level governance process, how this entire infrastructure is governed, who is in charge of it, who is in charge of individual data marts. If you want to obtain data from a centralized data warehouse or from another data mart, or if you want to integrate two data marts together, what are the lines of authority, who you need to ask permission for this, who owns a particular data piece, and so forth. So this is like an overall overview of business intelligence architecture. So this concludes part 2 of our video presentation on business intelligence. Thank you for listening.